Research, Training and Education, and Community Engagement. My name is Lindsay Osborne. If you don't know me, I am the Center's Training and Education Lead, and so we're so happy to have you here for our March seminar. So I'm just going to go over some quick housekeeping items before we get started. So you'll notice today that you're muted. And if at any point during the presentation you have questions for our speakers or just general questions, feel free to put them in the chat. I'll be monitoring that throughout the duration of the presentation. At the end, we can work to have your questions answered by our presenters if they are presentation specific. And then I briefly just want to mention our upcoming events and seminars before we hop into today's presentation. All of our events and seminars are always on our events calendar on our website, which I'll pop that link into the chat box here in a minute. I want to mention that next month we do have our usual monthly seminar on April 26th at 9 a.m. For this, our speakers will be presenting on some of the findings from the American Conceptions of Health Equity study called ARCHES. And our presenters for this presentation are Principal Investigator Dr. Sarah Willen of the University of Connecticut, as well as the co-investigators Dr. Colleen Walsh of Cleveland State University and Abigail Fisher-Williamson of Trinity College in Hartford, Connecticut. And then you'll also see that we have a special event next month, which is hosted by Swetland Center's Gwen Donnelly. She's an epidemiology and biostatistics PhD candidate, as well as a predoctoral scholar here at Swetland. And so Gwen will be hosting a lunch and learn on April 27th at 11:30. And this is designed to really help you navigate life after a PhD program. So she'll be talking about some tips for identifying career pathways after completing your degree, the job application process, interviews, and then ultimately selecting a position. So she'll be sharing some of her own personal experiences, and then we'll be having a Q&A session and kind of an open discussion at the end. So her time as a PhD student is actually coming to an end, and she'll be defending her dissertation this Friday, the 25th. And she recently accepted a position with the National Poverty Fellows Postdoctoral Fellowship, which is at the Office of Community Services in Washington, D.C. So I just wanted to highlight those two upcoming events as well before we jump into today's presentation. All right, and without further ado, I would like to briefly introduce our three speakers for today. So we have Dr. Kenneth Loparo, who is the Arthur L. Parker Professor in the Department of Electrical, Computer, and Systems Engineering at Case Western, and is also the Director for the Institute for Smart, Secure, and Connected Systems here at Case. So Dr. Loparo has been on the faculty of the Case School of Engineering since 1979. He's a Nord Professor of Engineering in the Department of Electrical Engineering and Computer Science, and holds academic appointments in the Departments of Biomedical Engineering and Mechanical and Aerospace Engineering. He's received numerous awards, some of which include the Sigma Z Research Award for contributions to stochastic control, the John S. Dakoff Award for Distinguished Graduate Teaching, and the Tau Beta Pi Outstanding Engineering and Science Professor Award, just to name a few. We also have Nick Barendt with us today, who is the Executive Director for the Institute for Smart, Secure, and Connected Systems here at Case. And he's also the Co-Executive Director of the IoT Collaborative, which is a partnership between Case Western and Cleveland State University, which leads change by using data to create value for business, industries, communities, and governments. Nick is also an adjunct senior instructor in the Department of Electrical Engineering and Computer Science at Case Western. And then we also have Christina Yoka with us today. Christina is the Chief of Air Pollution Outreach for the Cleveland Department of Public Health's Division of Air Quality. So Christina and her team respond to neighborhood level air quality concerns through technical analysis and community education. She's responsible for air quality outreach program direction, engaging stakeholders, and overseeing certain air permit regulatory actions at Cleveland facilities. And since joining the CDAQ in February of 2018, she's led the development of community community air monitoring initiatives that engage local organizations, researchers, and youth. Christina was the Clean Transportation Program Director at Earth Day Coalition, which is a U.S. Department of Energy Clean Cities Coalition from 2014 and 2018. She's served as the local primary investigator on multiple federal awards for reducing emissions in the transportation sector, such as the Midwest Evolve, which is the Electric Vehicle Opportunities Learning, Events, and Experience Multi-State Partnership. So without further ado, I will let our presenters share their presentation and we can go ahead and get started.
Is that showing up correctly?
Looks great.
All right. Thank you, Lindsay and the Swetland Center for allowing us to come and speak today about this project, which is we find pretty exciting, and as well as the project itself and the impact, the collaboration that's ensued because of it. So we're going to be sharing some insights around increasing our understanding of fine particulate pollution, PM2.5, through deploying a network of low-cost air quality monitors. So I'm Nick Barendt. If we'll, brief overview, provide introductions for all of the team. Just summarizing what Lindsay just discussed. We'll talk about the environmental impact on health and how this impacts our region. We'll provide an overview of this project. USignite is the sponsor, along with the National Science Foundation. Talk about some conclusions and lessons learned, and then future directions, and hopefully I have some time for discussion of any Q&A. So Christina, do you want to introduce yourself?
Good morning, everyone. Yeah, thanks again for having us today and including us in the presentation. As Lindsay mentioned, I am the Chief of Air Pollution Outreach for the Cleveland Department of Public Health, Division of Air Quality. Been here for approximately 4 years now. And in a nutshell, I'm responsible for anything that has to do with community engagement, public health, and air quality. And that includes educational events, outreach opportunities, and a lot of special projects.
Thank you. Ken.
Yes, Ken Loparo, and as Lindsay said, I'm a faculty member in the Department of Electrical, Computer, and Systems Engineering in the Case School of Engineering at Case Western Reserve University. And I'm also serving as the faculty director for ISSACS. And I am the co-academic director of the IoT Collaborative, which is this regional partnership that Lindsay mentioned between Case Western Reserve University and Cleveland State University, all around the ideas of economic development, community impact, and the industrial Internet of Things. As Lindsay mentioned, I've been a longtime faculty member at Case. I joined Case in 1979, so I am completing 43 years here as we speak. Nick?
Nick Barendt, as Lindsay mentioned, Executive Director for ISSACS, Co-Executive Director of the IoT Collaborative with our partners at Cleveland State, which has received significant funding from the Cleveland Foundation to support efforts like this and help drive these kinds of collaborations. Christina, I will advance the slides for you.
All right, you can go ahead to the first one here. So I'm going to start off today's discussion just kind of providing the Cliff Notes version of Cleveland's air quality status, a little bit about our history within air pollution regulation, how regulation has changed, and then kind of some basic information about what pollutants are, what are the ones that we monitor for, and how does all this come into play, which is the focus of today's presentation, which is the Tetrad Air Sensor project. But I'll just provide that brief background for your information. So our organization, we are a delegated Ohio EPA local air agency. So what that means is that we are contracted with Ohio EPA to ensure that all of the rules and regulations of the Federal Clean Air Act of 1970 are being followed. We do that through an enforcement team that's responsible for responding to neighborhood level complaints about air pollution concerns. So this can be anything from my neighborhood smells, and I don't know what the smell is, to open burning, to I see some strange color smoke coming out of a smokestack, and I want to know what that is and if they're allowed to be doing that. We also have a permitting team. They receive permitting applications from facilities that may require a state of Ohio EPA permit. And they review the permit application, review local rules, state rules, and federal rules, write up a permit recommendation that gets submitted to Ohio EPA, and then that Ohio EPA then issues it. We also have a monitoring section. And so today's presentation is going to focus heavily on that and what our monitoring team does. But they are responsible for operating an ambient air monitoring network that goes throughout all of Cuyahoga County. There are approximately 15 monitoring stations throughout Cuyahoga County that take air samples for different types of air pollution. I'll go into what those pollution levels are in a few slides. But that is the structure of the Division of Air Quality, are those three primary sections that all have a regulatory enforcement component. But as indicated on the slide here, we've been doing some work in the Cleveland area in some form or other since 1882. Nick, next slide. In the 1890s is when you actually started seeing air pollution regulation roll out. Cleveland was one of the first cities to have a brew of smoke abatement. So we were responsible for, in the city of Cleveland, looking at smoke as a nuisance and trying to implement ordinances to reduce the impact that smoke was having on the community. So as you can see on the couple of pictures here, back in the 1890s, you would see dark, heavy plumes of black smoke. And this would be from everything from transportation on like rails and ships to facilities, electricity generation. And you would just have these dark, dark plumes. This would also lead to particulate matter deposition. So people's homes and their real estate, and if they hung up clothes out on lines, they saw quite a bit of property damage. And so that made the community members kind of say like, hey, we need something to address this. And so in 1892, you had your actual first ordinances put in place to try to get voluntary reductions from local facilities to monitor their emissions and try to reduce it. This ultimately led, so there were some ordinances that were put in place, there was some violations that were issued, but it was seen more as an educational mechanism versus a regulatory one, even though there were City of Cleveland ordinances that were put in place. So then you jump ahead to about the 1940s. Next slide, please. And the problems were still continuing. You still saw, like along the rail lines, you'd have the dark smoke, you would have use of burning of coal that would lead to the particulate matter deposition, and just these really poor levels of air quality within the city of Cleveland and overall throughout the state, not just here locally. So we did see some additional ordinances that were passed, and that's also when we established the first Division of Air Pollution Control. And so this was in 1942. And this was a result of all of this industry still being in place and still making quality of life hard for individuals and having potential health impacts. But again, at this period of time, a lot of what they were looking at for the impacts of air pollution was on property damage and how it was impacting individuals financially. It was less about health and it was more about the property damage and the impact it was having on the dollar, basically. So then again, you jump ahead to the 1970s. Next slide, please. And the issues are still persisting. But what was happening is in the 1960s and the 1970s is when you really started seeing the environmentalism movement start to take place. In 1969, Cleveland has the claim to fame for the Cuyahoga River burning, which was the last time the Cuyahoga River burned, wasn't the first. And that just really caught a lot of national attention. And it was just all of the right conditions were happening where people were starting to pay attention to, hey, rivers are catching fire. And you also had Rachel Carson's Silent Spring come out. So then they started thinking about what is, the health impact. So in 1970, you have the establishment of the Environmental Protection Agency, which also ended up leading to the establishment of the Clean Air Act of 1970. The Clean Air Act of 1970 is the first time that any regulatory action was really put into place that had a real bite to it. So there's actually enforcement capabilities of that rule. There were some previous attempts at it, but nothing really took the impact that the 1970 amendment to the Clean Air Act had. That's also how we started getting mobile emission controls put into place, and started being able to control both facility emissions as well as being able to control emissions that are coming from vehicles. And ultimately, what this put into place was something called the National Ambient Air Quality Standards. Next slide, please. The National Ambient Air Quality Standards, which were put into place, the NAAQS, you'll hear me say NAAQS, put into place in 1970, identified 6 criteria air pollutants that were deemed to have the worst impact either on the environment or human health. So those 6 pollutants are ozone, particulate matter, carbon monoxide, sulfur dioxide, nitrogen dioxides, and lead. Of course, this was about the time, so like with lead, it was produced by both facilities as well as vehicles. That's about the time that you start seeing lead being removed from gasoline. Nitrogen dioxide, sulfur dioxides, they're going to all be emitted from the burning of fossil fuels, and they lead to the development through a chemical reaction that occurs with sunlight to the production of ozone. So ozone is basically, it's just 3 oxygen atoms. And if you think about ozone, there's a little saying that says it's good up high, bad nearby. So we want it up high in the atmosphere. When it's down at the surface level, then it's causing a lot of damage to lungs. It causes damage to plants, and it's very harmful. And then the last one, which is going to be the focus of today's presentation, is particulate matter. The combination of these 6 pollutants, there's been a 78% reduction in each of these pollutants since the enactment of the Clean Air Act in 1970. Now, I have to add a caveat here that even though things have gotten a lot better, there's been a 78% reduction in these pollutants, that doesn't mean that we're there yet. The National Ambient Air Quality Standards have certain limitations on the amount that's allowed into on either a daily basis or on an annual basis. And so we're currently meeting those standards for all 5 except for ozone. Ozone, in the Cuyahoga County region, we are in what's called moderate non-attainment. So we are not meeting the standards for ozone. Particulate matter, there's likely going to be a reduction in that standard from where it is now. And when that reduction occurs, we'll likely be not meeting those standards. But that's actually kind of a good thing because that requires the continual improvement and continued controls being put into place. So since the amendment of 1970, we have seen significant improvements, but it's also based off of where the monitoring network is located. So as I mentioned, we have a monitoring network throughout Cuyahoga County, but this is where some of the projects like we're going to talk about today that come into play. We can't be in every block and we can't be in every neighborhood. So having low-cost sensors to help supplement some of the material helps us with some of the work that we do. Next slide, please. The sensors that Nick is going to talk about today, the Tetrad sensors, they are pulling in air samples for particulate matter. And particulate matter, it can be a solid, it can be a liquid, but basically it's the suspension of particles in the air. The smaller it is, the more harmful it can be. So the smaller it is, the deeper into your system it can get and cause more harm. Next slide, please. And one thing I didn't mention actually on the previous slide is that you're going to hear us refer to the different sizes of the particulate matter. So you'll hear us talk about coarse particulate matter, which is PM10, or fine particulate matter, which is PM2.5. And again, the smaller that particulate matter, the smaller that particle, the deeper into your body it gets. Basically, you breathe in the particulate matter, gets into your lungs. The PM10 gets trapped at the alveoli. Anything smaller than 2.5, though, can get through the alveoli of your lungs and into your bloodstream and has been known to cause impacts on thyroid. It's been known to get into your endocrine system. So it can get pretty deep into your body and cause some pretty negative consequences. On a daily basis, some things that you might see is if you're somebody who has asthma, you may have a harder time breathing. You might have greater instances of asthma exacerbations. If you have any other type of lung condition, this is going to really impact you. But there's a lot of different health ways that breathing in particulate matter, ozone, or any other pollutant can impact you. So then finally, next slide, please. How do you know when you leave your house in the morning if it's a good air quality day or bad air quality day? You probably all have smartphones now, and there are air quality alerts that go out. So the air quality index is basically a scale that will tell you how good or bad the air quality is. On days that it's in the green, that's a good day. When it starts getting to 50 or higher, so it's yellow, that's when, if you are really susceptible to the impact of air pollution, like you have really bad asthma, really poor lung condition, poor lung capacity, it might start impacting you. And then you start getting into the yellow areas that it just increasingly impacts you more and more. So you can take a look, you can call our hotline in the morning to find it, go to the weather channel, or most weather apps are going to have what is today's air quality index value. If you're in good health, if it's a yellow day, more than likely you'll be okay. But if you do things like run or play sports, you just might want to just pay attention to how your body is feeling that day and just make adjustments accordingly. All right, I'll turn it back over to Nick now.
Thanks, Christina. So I'll talk a little bit about the technology here that we've been deploying, a little background. So the organization that funded this work is called usignite. They're funded by the National Science Foundation in a broad area that we might think of as smart cities. Everything from high-speed broadband deployments to data and data ingestion, data cleaning, data analytics, et cetera. So Cleveland is one of the original usignite smart gigabit cities. Digital C, a nonprofit in the region, some of you may know, is the partner for Cleveland with usignite. And as I mentioned, they work closely with the NSF, and they help co-organize a smart cities conference called Smart Cities Connect that happens to be happening in Columbus in a few weeks. And we have some discount codes, et cetera, if people are interested in attending that. And it'll be touching on infrastructure, smart cities, air quality, and a bunch of other related topics that might be of interest to this audience. So usignite published an opportunity in 2020, air quality improvements to mitigate COVID-19 deaths. It's been shown that air pollution, particularly PM2.5, increases COVID death rates. And we had an invitation to submit a proposal for communities interested in reducing air pollution by deploying dozens of sensors, not the handful of super high quality sensors that Christina's team manages, but some lower quality ones that were low cost that can improve the temporal and spatial understanding of the regional airshed. So we've been given 50 of these monitors. We'll show you a little about what the monitors look like. So the project is to deploy and maintain these monitors and use the data from the system to improve health outcomes for the region. So the company is a spinoff out of the University of Utah. It's called Tetrad, and the monitor is about this big, fits in the palm of your hand. Has some ingress points for air to flow in, and used for indoor or outdoor monitoring. They're about $250 each. Measures particulate. It claims 1 micron, 2.5 micron, and 10 micron. Anything below 2.5 micron is very difficult to measure with these technologies. Some oxidizing, reducing species, temperature, humidity, and location. Has a GPS sensor. Transmits data to the cloud, in this case through their backend system in the Google Cloud, over a Wi-Fi connection, which we'll talk about some of the challenges there. And the devices are weatherproof, but not waterproof, which makes the deployment a little tricky. You'll see on the lower picture here, similar to how we deployed a number of our sensors. This is a PVC end cap that has a portion of the bottom cut out to allow airflow, but the overhang allows you to keep rainwater and snow from getting down into the electronics, particularly if these are not mounted under the eaves on a building or something like that. And the pages, oh, there we go. So I want to make sure we talk about this and our partners. This is a broad coalition that was brought together to work on this project. So Digital C, as I mentioned, is the nonprofit local partner for usignite. They've been critical in this project in helping us manage it. And then ISSACS, the institute that Ken and I represent, Christina and Brian Sokolowski at the City of Cleveland, Department of Public Health, and particularly the Division of Air Quality, the IoT Collaborative, and our partners at Cleveland State and the CSU Tech Hub, and then Cleveland Neighborhood Progress. We'll talk about some of the roles here. So our goals were to investigate the correlation of PM2.5 on the incidence of COVID-19. We'll show you some of the data collection to help support that, and then share the resulting data and insights for the region. Understand the characteristics of these low-cost monitors and how they can add to additional information to the existing data sources to gain a more detailed understanding of the regional airshed, and then develop a platform for the collection and analysis of air quality data and make it available to other researchers, which I want to make clear on this call. If there are researchers who are interested in this data, we are happy to make it available to you for your study and analysis. So talk a little about our methodology for the deployment of these. So we chose a phased deployment strategy. Phase one, we determined learning. This was deploying 5 monitors to allow us to develop familiarity with the monitors themselves, the provisioning, the connection, the data streaming, et cetera. So critically, 2 are co-located with the City of Cleveland Division of Air Quality's EPA gold standard, if you will, the Teledyne T640X. One at the GT Craig site, which is sort of downtown near the post office, if you're familiar with that area. And then one at what's referred to as the near road sensor out at I-480 and 271. This gave us some sort of ground truth reference for the PM2.5 levels detected by the Tetrad device and being able to compare it with the Teledyne devices. We have 3 at the partner. So one at the Midtown Tech Hive, Digital C is located, one at CASE, one at Cleveland State University. The second phase is really about scaling once we have these monitors up and running, and learned about the deployment, built the processes to track the installation checklists, et cetera. And our intent was to provide dense coverage within the city of Cleveland and then broader coverage across the county. As Christina mentioned, the City of Cleveland's Division of Air Quality mandate is for the county, but we really wanted to make sure we had better understanding of what's happening within the City of Cleveland at a finer granularity. So we had to recruit hosts for these, and we were able to recruit 2 amazing hosts to support this. One being the Cleveland Public Library, which has branches pretty well dispersed within the city's footprint. And the other one being the Cuyahoga County Public Library, which has branches distributed around the county. Excuse me. A little froggy this morning. And both of these systems have, IT directors and facilities folks who could help with the installation, deployment, Wi-Fi provisioning of the devices. So we're currently in wrapping up phase 2 and moving into phase 3. Phase 3 is really targeting neighborhoods with suspected high PM2.5. And this is in partnership with Cleveland Neighborhood Progress. So they're recruiting some sites that we want to learn a little bit more based on some anecdotal information about what's going on. So we've deployed one of those monitors to date in that group, and we're ready to deploy the next 2 or 3 in the next month. Right now, we have about 40 monitors deployed and operational. This was the original deployment plan. So you can see the City of Cleveland footprint with the branch, Cleveland Public Library branch is circled in purple, and then the county with the yellow circles across the county library. And then there's a few little blue triangles showing some of the co-located facilities. In terms of the data pipeline, we had a graduate student who just finished up in December from the School of Engineering, Andrew Szabo, who built the data pipeline. And if we start at the monitors down here in the bottom left, they transmit their data, as I mentioned, through Wi-Fi, which creates some challenges, and Christina and Ken will talk about that at the end, over Wi-Fi into a cloud hosted in the Google Cloud environment that Tetrad runs. And then using their data APIs, we could extract data into the Amazon cloud system where we run a lot of our other systems, and then move that into what's known as a time stream or time series database. And that updates every few minutes. The data from the Tetrad API updates every 2 minutes. The devices sample PM2.5, temperature, humidity, GPS location, et cetera, tag all that data and send it upstream into the database systems. And then the Ohio Department of Health COVID-19 dashboard, we can scrape data from that on about a weekly basis with COVID case data by zip code, and then put that all into the same time stream database. So it makes it straightforward to do correlations and queries. And then we built, or Andrew built a little website to provide visualization. I should mention Andrew's work is going to be recognized at an award in Columbus at the Smart Cities Connect conference in April, one of the Smart 50 projects. So this is a little animated GIF of the dashboard running and the visualization. This is from data from a few weeks ago. So it's automatically incrementing across the top, which is the PM2.5 data. And you can see us highlighting different zip codes, and you can see the case counts and stuff showing up in the top right. And you'll see the colors changing on the monitor locations from green to yellow to red. And the scaling on this doesn't necessarily match the AQI data points that Christina showed in terms of the colored table. And you'll notice some monitors go on or disappear and then come back. And we'll talk about some of the issues there. So this is the baseline system to at least allow us to get a little bit of insight into what's going on within the region for these monitors. All right, we'll talk about what we've learned and some conclusions. I'll turn it over to Christina and Ken.
Christina? Okay, so thanks, Nick. So the initial study, I think, as Nick has pointed out, has confirmed that we can deploy and use these low-cost monitors to effectively look at what happens to PM2.5 over a fairly broad geographic area. Next point, Nick. One of the things that the monitors provide, because there's a much more granular spatial distribution for the monitors, we can actually determine what the PM2.5 concentrations are at finer temporal resolution, that is with faster update and sampling rates for what the values are, but also with a finer granular registration relative to the geographical area that we want to monitor, so that we can look at over time what's happening to the Cleveland airshed, both in terms of temporal patterns as well as geographical and spatial patterns. Nick? One of the things that you saw that Andrew built as part of his MS in computer science was the dashboard and the visualization. The data, of course, gets saved, and it can be in a spreadsheet or in a searchable database. But in order to make it effective and easy to use, having a visualization tool or a dashboard that allows you to see how the patterns are evolving in time, both in terms of what's happening in real time, but as Nick pointed out, you can go back and you can play the history and you can watch how the patterns have changed both temporally and spatially across the whole sensing area. Nick? The initial analysis that we've done, and as Nick pointed out, this was funded by ISSACS and the National Science Foundation, with a particular attention to looking at these Tetrad monitors and their effectiveness, because they are low cost, about $250 each. And the thought is they would be easy to mount and easy to deploy, easy to maintain, and easy to use, and that we could get an initial idea of the feasibility of looking at much finer granularity of monitors throughout a geographic region in order to monitor PM2.5. And we also looked at the feasibility of connecting that interface with COVID data and then trying to see if there were correlative patterns between where we saw PM2.5 concentrations being high. Did we notice any increases in COVID-19 infections? Because some previous studies have shown that PM2.5 can potentially be a vector for COVID-19. And in particular, as Christina pointed out, the smaller these particles are, the deeper they can get into the body through the lungs and ultimately potentially into the bloodstream. Nick?
Oops.
So there were installation challenges. I'm not sure what happened to the slide, but
I'm not sure what happened there either. Let me go back a slide. Hold on.
okay.
That's fancy.
Okay. Okay. So there were installation challenges. So the idea, was that the Tetrad monitors provided an interesting opportunity for deployment. But as Nick pointed out, the monitors were weatherproof and not waterproof. I'll be honest with you, the first time I heard weatherproof and not waterproof, I was a bit confused. But the issue is that, yeah, they can be out in the weather, but they also cannot be in a wet location. And that's why there was a little house around them to try to protect them. But that also causes a little bit of a challenge relative to making sure you can get air circulating in that device so that you're picking up proper PM2.5 concentrations, which are meaningful for the area that that's being monitored. Next one, Nick. Power. So all of these devices required AC power, which means that there had to be availability of AC power at the outdoor location. This was one of the reasons, rather than going to a residential home to look at deployment, we went to public buildings, the public library buildings, both in the city and in the county, because they were more amenable to helping us get AC power outside to power the devices where they were monitored. Nick? The third, of course, is that we need access to the data, and that requires access to a network. The Tetrad devices were Wi-Fi enabled, and that means that they had to be provisioned on a Wi-Fi network. Depending upon what the characteristics of that network actually are or were, in the case of the study that we've done, the provisioning can be more or less challenging on that network. And as you watch the visualization that Nick showed, you saw devices were going on and offline. And some of that was due to inherent issues with the devices themselves, and some of it was due to network instability, and these devices would drop off the Wi-Fi network, appear back on the Wi-Fi network, and the larger number of monitors that you have out there that you're trying to manage, the more challenging this coming on and off the network becomes, because you might need to send people out there to figure out, is it something physical with the device? Is it the network, or is it both? Next, Nick.
So I'll just say on that point, there are a lot of effort, a surprising amount of effort from the team standpoint had to go into the monitor deployment and maintenance. So creating checklists, creating the tracking spreadsheets, creating guidance for each of the hosts of how to locate and install the monitor on a particular building based on prevailing wind patterns, shading of trees, which can change the seasonality measurements of PM2.5 whether they're leafed out or not, as well as access to Wi-Fi and power. It became fairly complicated, and we still spend several hours a week looking at the monitor status, which devices are offline that we need to go gently poke and prod a host to go out and send somebody into the field to reboot the device or check the Wi-Fi issues, et cetera. There was a side project that was kind of fun. Christina, you want to talk about this?
Yeah, so kind of as a way to take what we're doing at that point in time for the sensor deployment and how do we start getting students and youth engaged in this, we were able to deploy in partnership with CASE and all of our project partners an air sensor Lego workshop. So this workshop was piloted at the Great Lakes Science Center. And what the students are doing here in each of these pictures is they are building an air sensor that is utilizing very similar types of technology as what is being used in the Tetrad units and other types of air sensors that are like that. So we piloted this project, it's about a 2-hour workshop at Great Lakes Science Center last summer. We had two different groups that were engaged in it. And their ages ranged from 4th grade up to 7th grade. And the students we gave them basic information and we led them through how to build an air sensor. It is an engineering workshop, so it's not easy, but you get to use Legos. And the students just had a good time of trying to figure out and how to build their, just how to build air sensors. Since the pilot at the Great Lakes Science Center, we have run this workshop at other just community organizations, at a couple different schools, and a few other ways of getting opportunities for students to get their hands on and start building it. Some of these workshops we pair with longer term instruction where we might go into a classroom for a couple different sessions and give more of a broader overview of air pollution. We've paired this with citizen science, we've paired this with environmental justice, but it's a fun workshop and it's something that we continue to offer, and we're happy to deliver it. If you have know of any groups or community organizations or schools that might be interested in hosting us for a workshop, we'd be happy to do it.
All right, future directions.
So we're certainly continuing to deploy sensors, and we're collaborating on related activities as we go forward, in particular in working with Christina and her group. Mm-hmm. We need to overcome, though, some of the challenges that were observed in the initial study. And in particular, it's looking for low-cost monitors that have some of the characteristics that we viewed were not favorable based on our previous study. In particular, that those that can operate over extended periods of time on battery power. That is eliminating the need for having an AC power source out at the device. If in fact we can achieve that, that will allow us to mount these and use these in a variety of different locations that might not be associated with a commercial, industrial, or residential facility. Nick. They need to be waterproof. We need to get away from just being weatherproof and waterproof so that we can mount them in areas which will be exposed to the weather and to water, and not have to worry about whether or not it's contaminate the measurements or ruin the units. Third, in many of the instances where we would like to be able to monitor, Wi-Fi may not be available. An obvious option is a cellular link, but that requires a cellular data plan, and that can be expensive depending upon the amount of data that you want to push from the device into the cloud to get to the database. So we want to be able to look at other options. Nick? So one of the things that we also want to be able to do, and Christina mentioned it when she talked about the EPA sort of air quality parameters, certainly PM2.5 is an important measurement that we want to be able to make because of its importance in respiratory health and the impact that it can have. But we also would like to have a sensor module that not only provides PM2.5, maybe provides temperature, relative humidity, GPS, so it's also got location, of course, but you may want to be able to add additional sensor modules like ozone, maybe CO, NOx or nitrous oxides, sulfur oxide, and hence we want a platform that is more flexible and can be added to or built upon as we continue with trying to find ways of diversifying the number of measurements that we make at each of these remote sites. Nick? So one of the things is that we are currently looking at a sensor technology. In fact, we now have one of these devices that we're looking at for a study potentially moving forward that would utilize other network options rather than Wi-Fi. And we've been thinking of low power wide area networks. And in particular, we've been specifically focusing on LoRaWAN or long range wide area networks to help, number one, manage the overall power consumption, because a major power drain on these devices is not necessarily when you're collecting the data, but it's when you're going to transmit and want to move the data from the device up to the cloud. But using a low power strategy like LoRaWAN, we can reduce power consumption, assist with device deployment, and hopefully get away from having this Wi-Fi issue where we have to worry about not only provisioning on that network, but also the stability of that network based on keeping these monitors alive and providing data. So we're currently looking at a new generation of wireless PM2.5 and extended capability air quality monitoring devices.
I think I saw Andrew Curtis on the call earlier. He's involved in procuring that device for us.
Yes, thank you, Andrew.
We hope to have it deployed in the next couple of weeks at one of the City of Cleveland Division of Air Quality Monitoring sites so we can co-locate it.
So Christina?
Okay, so this has been a really incredibly valuable partnership for the Cleveland Division of Air Quality. We've really appreciated the opportunity and the support to be involved in this large scale sensor deployment project. As I mentioned when we first started, I've been involved in sensor deployment projects since I started in 2018. When I started in 2018, though, there was a little more hesitancy, I would say, on EPA's side to be able to accept the data. The low-cost sensors do have a tendency to read higher than what you would get with an EPA monitor. But these types of projects allow an opportunity to co-locate, as we've mentioned quite a few times, a sensor at an EPA site. And then what we can do from that is develop a correction factor of how consistent is that sensor with reading data compared to our EPA monitors. So I just want to emphasize how valuable being able to be involved in this large scale deployment project has been. Going forward, I think that this definitely helps prepare us even further to continue to partner with community organizations on deploying low-cost sensors. When communities are interested in deploying this type of sensor, it's really important to keep in mind how are you deploying it and what types of quality assurance and quality control practices are you putting in place. So how do you know that the data that you're collecting from these sensors are good data? And this large scale project has helped us develop some of those practices. So we look forward to continuing to partner with other community organizations. We've done some other deployments with Purple Air Sensor, which is a similar type of sensor. So continuing to build on that. Continuing to build on collaborations with youth organizations and schools that are interested in air pollution, environmental justice, citizen science, health impacts, all of these things are connected. Air pollution is going to be worse in communities that have environmental injustices. One of the things we talked about in this project was having a higher density of air sensors within Cleveland versus Cuyahoga County. And part of that reason is that the city of Cleveland is subject to more air pollution sources through both facility emissions and mobile emissions than Cuyahoga County at large. So even though the city of Cleveland is, just a percentage of overall Cuyahoga County, we bear the burden of where the air pollution sources are. So we look forward to continuing to work with any schools, youth organizations, community organizations that are interested in exploring these topics and how these topics are impacting their constituents. And then lastly, as I mentioned, we have the Air Sensor Lego workshop. This really is a fun workshop. We're happy to deliver it. We can make adjustments based off of the age and based off the interest. Generally, we schedule it in 2-hour blocks, and we can accommodate up to about 20-ish students at one time. So I'm happy to share my contact information after this presentation. And if if this could be a Boy Scout group, a Girl Scout group, summer groups, whatever the case might be, feel free to reach out to me if you're interested in bringing this workshop to any of the youth that you're involved in.
All right, so we'll move to Q&A. Let me go ahead and stop the screen share.
Thank you all so much for such a wonderful presentation. I think this was really great, super important work, kind of at that intersection of like engineering and environmental and public health. So I really enjoyed it. I know we do have some questions in the chat, so I'll kind of start from the beginning. There was the first question we have is kind of a higher level looking to the future. So how do you anticipate using the data to improve air quality across the county? Are there next steps that have been identified after gathering this data, and kind of what does that look like?
Christina, do you want to take that one?
I'll take an initial stab at it. Yeah, so I would say we still have quite a bit of analysis we need to do. So even though we have all this data available now, I think what we need to do is look back at it and look at where are we seeing patterns. So are there certain locations in the city of Cleveland that we're continuing to see higher levels of particulate matter? And if there are, then at that point, we can take an analysis of what's happening within that community. Are they close to facilities? Are they close to transportation sources? But what are some of the potential sources that can be contributing to those higher levels of particulate matter? The other thing that we would need to look at is, are there patterns, based off the time of day, and just where is this? And the way this could help, we need to do that analysis, but the way it could help is with us direct our enforcement efforts. So if there are a lot of facilities that are in that community, one thing that we could be doing as a result of it is kind of take an eye, getting an eye out to see what's happening there, what's that landscape, and are they in compliance with any of the regulatory standards?
The other comment I'll make is the Tetrad devices use the exact same sensor as the Purple Air monitors use.
Mm-hmm.
Purple Air monitors have been deployed for slightly longer and have developed a more comprehensive set of compensation factors from the raw data readings to the calibrated values. So part of this deployment with Tetrad has been allowing them to develop better compensation factors, which are regional and seasonal, just given the nature of particulate pollution. So Brian Sokolowski, who's not on the call this morning, but it's the head of monitoring, working with Christina, regularly is working with comparing the Teledyne data to the Tetrad data at the co-located facilities. And there's some discrepancies, and as they're trying to look between multiple sites, some caused by fugitive dust and high winds in certain areas, and really trying to dial in so we have high confidence on the data being published.
Right, and that will continue as the device continues to be deployed, and you can refine these compensation factors over time.
Mm-hmm.
Great. Thank you so much for your response. Another question we have is, how long does it take for the monitors to get an accurate reading? And there's a suggestion of, could it be possibly mounted on a car roof and parked somewhere for a day in a particular location? Is that, again, I wonder if that goes back to like being weatherproof versus waterproof, but yeah, there was just a question
There's a couple
about how.
things there. So given the nature of the sensor, if it's not great in a mobile setting, if it's moving very fast.
Right.
Maybe walking speed would be acceptable, but most vehicles, buses, etc., would create too much wind and disrupt the data capture and sensing mechanisms. They don't take long to deploy in terms of, you can physically mount it pretty quickly with a couple screws, as long as you again have Wi-Fi and AC power. The issues around compensation we're doing across the region, so you have a larger area of statistical support. If you just have a single point source, it's hard to tie it to anything known. But with the co-location, with the Teledyne reference units across a couple sites geographically distant, we can get some pretty good statistical analysis to look at root mean squared error.
If you have devices that can run on battery power and can be provisioned on other networks rather than a Wi-Fi network in order to get the data, there's no reason why they could not be quote unquote portable, in a sense that moved from one location to the other. But next, Nick pointed out, if you're driving on the freeway, your ability to get reasonable or meaningful data is going to be zip. It's just not going to happen. But if the question is that could I move it and then leave it at another location for a couple of days and then move it again to another location? The answer is yes, if you can solve for the power problem and the network problem.
Got it.
Yeah, and the other thing there, of course, is you want to, in most cases, the PM2.5 levels vary with a daily circadian sort of rhythm with traffic flow patterns, as well as seasonally. So if you're constantly moving the sensor around, you may have a hard time looking at that data through time at a macro scale.
That makes sense. There was some positive feedback on the Lego workshop, which I also thought was really, really cool. And there was a question about if, which you kind of started to touch upon, Christina, about sharing like the lesson plan for outreach. So I guess my question to follow up on that would be, would you be able to put your contact information or the contact information for people to reach out to if they want to coordinate and reach out and, maybe have that be a part of their outreach or lesson plan somewhere.
Yep.
And they can get in contact and coordinate that. There was a question about, have you looked into CareNet? I think I'm pronouncing that right. They're waterproof and solar powered and have options for other pollutant monitoring in addition to the PM2.5.
I don't think we've specifically looked at that monitor. We have looked at other monitors, and we have one in our possession, I think, as Nick pointed out, that we're testing and evaluating now, but we'll certainly look at that as an option.
Great. And then we have a comment from Sahara. Our group is looking at outcomes and inflammatory markers in COVID and would be interested to look at correlation with particulate matter. So I don't know if there's contact information that you would want to share in the chat. What would be the best way to move forward and possibly collaborating with that? So if there's a way for people to get in contact with you after this presentation to follow up or potentially for new collaborative opportunities, that would be great. So I know we're almost at time. I'm going to take the last comment from Tim in here. So this seems incredibly useful for monitoring local air quality. If linked to local EHRs, the electronic health records from hospitals, could be leveraged to track and study multiple particulate-driven diseases in Cleveland. Do you have any plans for that in the future as well? Is that something you'd considered?
We are considering that, and we have a project underway that we'll be able to release some information on very soon here. That is a proposal, and it's looking at that precisely.
Great. Wonderful. Okay, so I see all of our speakers have put their contact information, emails in the chat. So feel free to grab those here before we sign off if you have any other questions or want to follow up on potential collaborations. I just wanted to thank Ken, Nick, and Christina again for sharing this presentation with us. It was super insightful, and I think it's some really important work. So hopefully we'll all look forward to hearing kind of what happens next as a follow-up to this. So thank you so much.
Thanks, Lindsay. Appreciate the opportunity to chat today.
All right.
Thank you,
so
everyone.
yeah, we'll hop off.
Hey,
Thank
thanks,
you.
everybody.